Okay, so it's lesson 4. Today we're setting up SQL Server and we're going to connect our ASP.NET Everything Store application to it. So I'll take a few notes here as we talk. So we watched this lynda.com, this little 9-minute intro about SQL Server. And my question to you was, why use it? So he listed a whole bunch of reasons here. What's one reason you took away from there why we might use this technology? Okay. Very robust security model, different layers of authentication and authorization. So, absolutely. Typically, if we're going to use .NET as our development framework, the vast majority of the time we're going to use SQL Server as the backend. The integration and the performance is really good because it's all Microsoft code. Really? Only SQL Server. The vast majority, if we went and found 100 ASP.NET web applications out in production, I bet you 95 to 99 of them will use SQL Server as the database. So we talked about Visual Studio and that. So that video, he mentioned SQL Server 2008. I don't know if anybody caught that. And he said it's been around for 20 years. Well, that was 11 years ago. So it's now over 30 years old. So a product that's still very widely in use, we can assume it's probably a pretty decent product. Right? Things that are lousy don't tend to last in the market and take up adoption for that long. So there's new versions, not every year, but like, for example, there's a 2017, 2016, there was no version in 2015, there's a 14, 12, but most of them are interoperable. So I think we talked about it last week. A few people said, hey, I have an older version of SQL Server on my machine. Is that okay for the course? Do I need to upgrade? You don't. The only version that wasn't compatible was when they went from version 7 to version 2000. And yes, I've been using SQL Server long enough to remember that. I had to remove my version 7 and upgrade to 2000, and there was a lot of integration hiccups migrating those databases. Okay, that's a pretty good list. Anything else we should add to our list about why we want to use it? So SQL Server is one of only a handful of databases we're ever going to see used at the enterprise level. There aren't really very many products. This is one of the few, and we'll kind of look at the market share in a minute. There was one other important thing that he talked about for web development. Did anybody catch what that was? It was particularly relevant to us in a course where we're building web applications. Anybody catch what he said here? Lynette, you want to take a shot at it? It does integrate well, yes. But what did he say about web hosting? You got it. Okay. So typically, if you want to host a web application online and you want to rent server space somewhere, at least most traditional hosting companies, they're only going to give you 2 choices for your database management system. Virtually every hosting company will offer MySQL, but the only other system they're going to offer you if you don't want to use MySQL is SQL Server. Now, we looked last week at the cost for one core for an enterprise SQL Server license. Anybody remember what that cost per core? Yeah, it was about $14,000 US for a single core, right? So you don't want to run that on your own server, right? We want to pay a hosting company, then they've paid that license and they'll rent us space on their server. So I'll show you, for example, hosting plans. This would be typical. So I deal with a few hosting companies. This is one that I host a lot of stuff with. They're based in Western Canada and Saskatchewan. They have a data center in Quebec, and they have another data center in the United States in Colorado. And if we look at their hosting plans, so if we wanted to find the basic hosting plan, so shared hosting, which would be their cheapest. So their starter plan, what does it give us? We go to compare in detail. We get both MySQL and SQL databases an unlimited number. But if you wanted to use any other database system, they don't offer it. So if you wanted to use, say, Oracle, PostgreSQL, or something else, one of the other big ones, DB2, hosting companies don't generally offer this as an option. So unless we're going to get our own private server or deal with cloud hosting, basically our choices are MySQL or SQL Server. Instead of paying that $14,000 a year per core, these guys are paying it, and they'll rent us space on that server. They'll give us 15 gigs of disk space for, what was it, I think $10 US a month. That's a pretty good deal. So those are really our only choices, and SQL Server is much more of an enterprise level product than MySQL is. So that's an important thing to note. All right. So there's our pretty good list. Couple of different metrics I'll just quickly show you. So how popular is SQL Server? So here, this is up to date. So one ranking of the popularity of relational database management systems. You can see there's really the big three, and then there's everything else. There's MySQL, and then SQL Server. So these three really dominate the market share. Everything else is really far behind in terms of market share. Oracle's still first. I know that many departments, for example, in the Canadian government, it's kind of, they have an interesting technology mix. They use almost exclusively Oracle as their database management system, yet almost all of their application development is in .NET, both desktop and web. So they're that rare organization that uses ASP.NET for all their web properties, yet the back end is Oracle and not SQL Server. It's kind of interesting. So there's one metric. Here's another by a different set of methodology. And this is a few years old, but they have Oracle with a bigger share. And this is the commercial only. This is not small scale. So at the enterprise level, Oracle dominates, and then SQL Server second, and IBM, that would be DB2. Which I think you guys are going to have some exposure to in one of your other, maybe your advanced database course. I'm not sure. I know in the past they've used DB2 for that course. By the time you guys do it, that may actually be a course fully in SQL Server. So the database isn't really our focus of this class. However, I'll also just check this out. Being a DBA is a very underrated way to earn a living. So here's one survey. Not the sexiest job in information technology, but the demand is huge and it pays quite well. There's an average salary, but certainly experienced database administrators are making typically more than that. So if you like databases and you find you're good at them, don't rule that out as a career path for yourself. There's lots of huge demand for database administrators. That's pretty good, and you can see trending in the right direction. Okay, so what we want to do, we're going to set up an instance of our everything stored database. I'm going to recommend everybody set it up on their local machines for two reasons. One, it won't burn up any of your Azure credits, And two, it's just going to run faster. Obviously, if we're connecting to a local database, than all our pages connecting out over the internet to Azure and getting the response back. I will show you how to set it up on Azure as well, though. You don't have to do it, but I'll record it because the database you need to set up for assignment 1, that one you do need to set up in your Azure account. You can actually host and deploy your application online. So I will show you how to do that as well. So the first thing we need to do, just going to go ahead a little bit in this video. When he talked about this whole ecosystem of programs. So the really important one that we're concerned with in this course, well, there's two. There's the core engine, and that's what I asked you to install at the end of class last week. And I said, make sure when you install it, that you install the database engine component. Otherwise, you have the program, but no actual database server. So you had to check the first box in the components to install the database engine. So that's really the core product. Nothing else here really works if we don't have a database engine running. So the main tool that we're going to use is this tool called SQL Server Management Studio. So this is kind of a similar interface to MySQL Workbench, but much, much more robust, much more fully featured, much more powerful. So typically when you install the SQL Server, you download it, it typically comes bundled with Management Studio automatically. I'm going to have everybody check if they have that program, and if not, we're going to need to go and download Management Studio and install it, because that's the program we use to actually interact with the server, whether it's local or whether we're connecting to a remote host. So here's what I want you to check. You search, just put in the word manage, you should have some instance of Microsoft SQL Server Management Studio. Doesn't matter if you have a different version, that's fine. If nothing comes up saying Management Studio, then we need to go online and grab it. I think I have the link on Blackboard. If not, I will post it. So just give me a second and I'll check inside Tools and Resources. I may have to just add the link here. So I had the link for the download, but let's just see. If I click here, if you use the existing SQL Server download link, it'll jump you to this page. And up at the top, this is the downloads. These are the downloads I asked you to get last week. One of these, like the developer or Express Edition. So if you don't have Management Studio, if you scroll down to the bottom, under Tools, it's this first link that I've highlighted that says Download SQL Server Management Studio, the acronym abbreviation SSMS. So if you click on that, it'll take you here. And download this one. The second one is just an update package. So this won't work if you don't actually have. So you don't need really the upgrade package, just download this tool. It's not as large as the whole program, so it should download fairly quickly. And once you've downloaded and installed and run the installer, it's kind of like Workbench. It allows you to connect to any instance of SQL Server where we have credentials. So we can connect to our local server, or we can connect out to a web host like Azure where we have a database that we have access to. So I would recommend pinning it to your start menu so you got easy access to it, because we're going to probably use it in every class. Now, Visual Studio does have, technically you don't absolutely have to have this. You can connect to your databases also through Visual Studio, but I don't recommend it. I'll show you how to do it, but A, it's much slower than Management Studio, and B, most of the features of Management Studio and many of the convenient things that are there are not in the Visual Studio version. So if you really want to work only in one program, you can use Visual Studio. Typically when I'm developing, I have both Management Studio and Visual Studio open. Every week when I come to class, I'll just have those open because I'm going to need them every week. So I'm going to open up Management Studio. So I don't quite have the latest version. I've got 17.8.1, doesn't matter. So much like in MySQL Workbench, you get this login window popping up as soon as you open the program. It's asking, what database server do you want to connect to and what credentials do you have? So typically when you set it up, so when you get this window, if you click your dropdown might be blank. You may not have any servers listed here. So if we want to browse to our local server, if I just click this dropdown, if there's nothing here, there will be an option that says browse for more. So click browse for more. And that pops open this little window, and notice there's a tab here that says local servers. So I want to look for my local instance of the server. So if I expand this database engine node, it shows me my computer name. So I'll just click on my computer name. It may say localhost. Typically, it will say whatever the computer name is in Windows. Should show up there. So just click OK. And now we have two options for authentication. One option is Windows authentication. This is the default. So when you installed the server, it asks you how do you want to authenticate. If you don't change anything, it just uses your Windows login. As long as you're a valid Windows user, you can connect to the server. So that's, I think, how I've set mine up, and that's probably how most of yours is set up. So at this point, you can just try and click connect and see if it connects. The other option, and we'll need this when we connect to the remote servers, the other option is to change this to SQL Server Authentication, and that's where we have to put in a username and password. So when we're connecting to Azure, we're going to have to do this. Windows authentication is no good. Our databases on the actual server need a login. So I think mine should be set up with Windows authentication, so it just disables the username and password. So I'll just try and click connect. Okay. So it doesn't like this because when I set mine up, I changed it from Windows authentication to SQL Server Authentication with username and password. So most of you won't have to do this on your local server, but I do. So the default login, if you choose this, is the username is always SA, which is short for system admin. And then it prompts you to pick a password. And I'll click remember here so that next time I log in, it doesn't prompt me to re-enter. Just like in Workbench, there's that store your password in a vault option so that you can just open your connection without putting your password in every time. So all I need to do to connect to my server is just open the program, pick my server, click connect. So then I'll have two different windows here. If you don't see these windows, you can turn both of them on through the view menu. So this window up the top is my list of registered servers. You guys don't quite need this yet, but I'll show you what it does. And then the other window is called down here is called the Object Explorer. So you can see I'm connected to my local server. So you do see a similar window when you connect in Workbench. And here I have a databases node. Unfortunately, I can't make the font any bigger. So this shows me the databases I have within my local server. So I have 3. So I'm going to create a new one in a minute. This registered servers, this shows me all of the connections I have stored. So each of these folders, these are all different hosting companies where I have accounts and I have SQL Server databases. So typically I have different clients and some are hosted with one company, some are hosted with another. So for example, within Loosefoot, I have 6 different SQL servers, each one with a different username and password, right? Because they're all separate client accounts. I don't want to share those logins from one client to another. So if I want to connect to any one of these databases, because I've stored my credentials, I can just double click it. So if I double click it, it'll take a minute to connect because that database is out on a server in Quebec. It's not local, so it doesn't run as slowly. And then I can go, I'm going to see all the databases on the servers, but I only have access to one of them with this login. There's probably 100 different databases on here, but each one belongs to somebody else. And I only have access to my own. So here's all the databases. There's a lot on here. So here's my database, and here are the tables that I've created. So notice it's a little slow connecting to a remote server. When I open things up locally, right, it's pretty much instant. You can see how much faster it runs. So for our everything store, that's why I'm going to recommend it's easier if we do this locally in class. Just going to save us time and make everything run faster. So what we want to do is create a new database. I've put an SQL script up on Blackboard that will build some tables in there. And then I'll show you how to manually create a new table in a really easy way. And you'll probably want to do it this way for assignment 1. So first thing we're going to do is I'll just right-click the databases folder, new database. Now we could do this through, there is an SQL query window. We could write a create database statement, but I find the visual tools in Management Studio, they're faster. They save us from having to write a lot of code. So I'll click new database. I'll give it a name. I can call it everything store. And I'll just accept the defaults. This will actually create 2 physical files. One that has an MDF extension, Microsoft data format. One that has an LDF extension, that's a log file. And the default path where it creates these databases is program files, SQL Server, our version, and then there's a data, ultimately a data. So you can change if you want the databases stored somewhere else, but that's the default path. I usually just save them to the default path. So call it the everything store, don't put any spaces in there. So this will just create an empty database. So now I have the everything store, I expand it, tables, we have none. So now I'm going to go to Blackboard, I'm going to download my SQL script to my machine, and then I'm going to open it up and execute it, and it'll build the tables we need. So I've put the script actually in 2 places. It's both in tools and resources. I think I uploaded it there. Sorry, I meant to upload it there. I didn't, but it's in the week 4 folder. So right here, here's the everything store SQL script. So I'm just going to right click that and save that file. I'll save it into my COMP2084 folder. So now I've got a copy of the script on my machine. So now I can just click on File and Open File, browse to that SQL file. So a couple things I'll point out about the script. This is the hard way of creating the tables. There's a much easier way of doing this in Management Studio. Nothing wrong with doing it this way. So this looks mostly like the kind of SQL create table commands that you would have seen before. There's no inserts. We'll populate the data through our web application when they're connected. These are just going to build the 6 empty tables that kind of look like, right? I plotted out this ERD. We kind of sketched out the tables together a few weeks ago, and I created the relationship. So it's got these relationships. What things do you notice here that are different from the SQL commands? About 95% of the SQL we use with SQL Server is the same as with any other type of database engine. So it'd be similar with Oracle, with MySQL, but each database version has a few of its own language commands. What do you see here that you haven't actually seen before? Okay. So we have 2 constraints here, for example. We've got a primary key constraint, and we have a foreign key constraint. Brilliant? Right. So identity would be the same as what command in the MySQL database? How do we? Good guess. No. What is identity doing here? Right. So we don't use the keyword auto increment with a Microsoft database. Instead, we use identity. So that means the database will automatically assign unique numeric values to that field. So every table we create should have an identity primary key. Okay, in your assignments, the tables you're making need primary key fields, and those should have that identity set to on. Okay? We don't want users having to enter primary key values ever. Database should assign those so that we can ensure those values are unique. Notice also, if you look at this line here, so here's our product ID primary key, here's our order ID primary key. You'll notice one thing that's different about them. What's different and what do you suppose it means? Look at the very top line. Actually, I should turn my line numbers on. Normally it shows me. I go into options. Line numbers. Okay, so let's look at line 7 and line 27. What do you notice that's different, and what do you suppose that difference means? You got it. So we're going to have our products. All the product primary key values are going to start with 1,000 will be the first product. Our orders are going to start with 2,000. Okay, so when we create an auto incrementing field, we can specify what's our starting number. So I've chosen to use different numbers for different tables. Two reasons. First of all, I don't generally like starting at ID 1 because how confident are you if you're a customer at a business and you get an order and they say, congratulations, you have order ID 1, right? Probably not so much. So I'm going to start at a higher number, first of all. It's also just a way of differentiating, right? If I see ID 2000, I know this is an order. That couldn't possibly be a product. So what I've done is I've used 2,000 for orders and 20,000 for order details. Because again, there's going to be a relationship there. You don't have to do this. You could keep them all at 1. You could start them all at 1,000. Doesn't matter. But I also wanted to do it this way just to highlight that you have the ability to change the starting number, and this is how you do it. Your customer might say, I want my IDs to be 6 characters. Okay, great. So we know we'll start at 100,000 or 300,000, for example. What do you think the second parameter here is? If this is the starting number, what does the 1 mean in all these cases? Yeah, increment each record by 1. So again, if we want, increments of 100, we'd make that second parameter 100. If we don't want order 2000, 2001, we want order 2000, 2100, etc. So we have the ability. So this will default to 1, 1. Start at 1, increment by 1. But we can override it. So the categories, we're only going to have a few, so I just did 1, 1 for the categories. Yeah, it will default to 1, 1 if we take it out, but I was explicit about it. So I've set up the foreign key constraints as well. So for example, if we try to add a product, we don't put in a category, it'll throw an error. It'll say we need to have a category ID in here. So we've set up the script. If we want to check it, if I just click the checkbox, it actually just does a syntax check. It doesn't run the script, it just checks if there's any errors. So for example, if I leave out bracket and do a check, and it'll tell me you've got an error on line 4 and it'll highlight it red. MySQL Workbench does similar things. And now I want to actually execute this to build the tables. So I can just click execute here. Okay, it runs really quickly because we're local. And now if I come back down to my everything store in Object Explorer, there's a little blue refresh button right here. If I click it, we now have our 5 tables that were in the script. Okay, so there's no data in them. And we can check out our tables visually. You can do this in MySQL Workbench, but you can't see quite as much. If we want to look at the orders table, we can see all the columns, keys, data types. We can see any constraints or keys. These things are here. We also have a visual table designer. So if we want to create or modify our tables, we actually don't need to use SQL commands at all. So we'll create one more table. We'll do this manually. Sorry, we'll do this through the visual designer so that you see how to do it. So we had a couple of other tables that we said were kind of, for the moment, outside the scope. So maybe we'll add a country table. We'll just do this manually, where we have a country ID and then maybe just the name of the country, 2 columns. So we could write a create table script. There's a much faster way to do it. I also want to show you how to set up the primary keys and the auto incrementing. So I'll just right click on tables, choose new table. I am recording this, so this will be in the video. You can reference it for your assignment. Okay. So here, we can just type country ID, integer, uncheck allow nulls. To make this a primary key, I'll just highlight that field, right click, set this as a primary key. Now we also want to turn the auto incrementing on. So as we're adding countries, automatically IDs get assigned. So that's down here. In the column properties, right here near the bottom, there's a property that says identity specification. That means, are the IDs automatically assigned by the database? It defaults to no. If I expand identity specification, I can either just double click here or just click this little drop down where it says no and toggle it to yes. Once I click yes, these 2 fields become enabled and they both default to 1. So start at 1 and increment by 1. So they refer to those as the identity increment and identity seed. So I'm going to make each of these, just let them go as 1. And now I'll just put in name. Neither of these will be null. You must make sure you uncheck allow nulls before you turn the identity on. This field will be disabled so long as nulls are allowed. So you have to say field is not null. And now to save the table, just click Control S or save on your toolbar. And now it prompts me for a name. Run. So to create our database is much faster with this visual designer. If you prefer writing the SQL commands, by all means, do it. But this allows us to create our tables much more quickly. We don't have to worry about errors in our SQL syntax. So if I want to make changes to a table, I can just right-click. Notice it doesn't show up here. I just click refresh again. Here's my countries table. I could write an alter table command, or I can just right-click it and choose design. It just takes me right back into the visual editor. So to change the name, you've got to right-click it and choose rename. You just choose rename. But if I want to add, edit, or delete any columns here, I can just keep going. I could add more columns, rename. So it's really fast to modify the schema if we need to. And just when we're done with changes, click Save. So I'll show you a couple of other quick tools that are neat in here. I know you can do this in Workbench. So you have the ability to create reverse engineer your entity relationship diagrams. If you build the tables, you can drag them on and it will show you the relationships, and you can create and print out an ERD, which is useful. It also has a visual query editor. So if I want to create a complex query, but I don't want to write all the SQL, I can let Management Studio, in effect, do it for me. So here's what I do. If I go to Views, there's nothing in here. So I can make a view. And also, if this is a query I want to run regularly, I can save this query in the database. And then anytime I need to run it, I can just open Management Studio, execute the query. So for example, I have a customer who occasionally asks me for a usage report on his website. And it involves like 15 tables. To build it into the web application, I said, I'll do it, but it's going to take me a lot of work. And he said, well, couldn't you just run the report like ad hoc when I send you an email? So I created the query and saved it. And now anytime he wants it, I just have to log into the database, run the query, copy and paste the results in an Excel file, and here you go. So if I create a new view, I can add tables. So let's say we want to see all the products and have been ordered. So if I add them, because all our joins are here from our create table, and we want to see, I don't know, the name of the category, the product name, and then the order date, total, quantity, price, and I want to sort by order total in descending order. I can just, here's my execute button somewhere. It's hiding here. Run the query. Obviously, we have no results, but there we go. There's our query. So we didn't have to write any code. All our joins are already done. We can see the SQL. So if we want to modify the SQL, we can. And then we can save this as a stored query. Can save it as a view, and then we can just come into the Management Studio and execute this query anytime we want to see the data. So I won't save it, but we could. Actually, I'm going to grab that. I'm going to show you one other very useful tool. I'm going to copy my query results. I'll make a new query here, which will give me a blank SQL editor. I'll just paste in this query. If I can execute it, I get no results. But there's this super useful feature. Where is it? Hang on. It's this one. Include actual execution plan, this little button right here. If I enable this and run the query again, so I now get 3 tabs, my results, any error messages, and then it gives me this. It actually maps for me the performance of my query. So the primary key here took 13% of the resources. So I can see how my query is performing. So the sorting operation took 46% of the time to run this query. So if there's millions of lines and my application's running slowly every time I run this query, this shows me where those performance bottlenecks are. Maybe I want to take the sorting out of the SQL and add that into my application code instead. Maybe the results are going to come back much faster. So this allows us to profile and fine-tune our queries to try and optimize performance. Really helpful when we're working with lots of users and lots of data, but we want to try and run things as fast as possible. So we can turn this window on and off. It's off by default. So we've now got our database set up. So for your assignment, remember you need a minimum of 2 tables. You don't need more than that. So you can write a simple create table script and make sure you add the foreign key reference, or you can use the visual designer to do it. If you use the visual designer, you can actually create the keys afterwards under the, just by creating a diagram. So if I create a diagram and add on, let's say, our product and category. Oh, sorry. I wanted to add our countries table. Now, I didn't put a country ID foreign key here, but if I did, all I have to do to create the relationship is just choose new relationship. Sorry. I think it's under. So I can actually create my relationship or constraint in here. I forgot to click add. Right, so when I click add, it asks, what's the foreign key? So I can actually create it through here. Right, so is it country ID to what? Or you can just add the foreign key through the query window. So in your assignment, you basically need one, you just need one foreign key. I'm not going to save that. So our database is set up locally now. So now we want to open up, actually, I'm just going to open up Visual Studio. It's probably time for us to take a pause. So just open up your everything store. We may as well get it launched. So we can just hit debug and start without debugging to start our local server. And then we will take a break for 20 minutes. We come back, we'll look at, okay, how do we get this talking to this? So we can see the tables, and then we can start adding, reading, editing, and deleting information. Okay? We'll be able, this actually won't take us all that long. So we'll be able to get all this working relatively quickly now that we've got it set up. Okay? So we will take a break here. Come back in 20 minutes.